This Zoom session is being brought to you by the Fractal Bullseye Water. All right, now, a quadratic, section 3.1. A quadratic function of the form f of x is ax squared plus bx plus c. Its graph is this U-shaped curve called the parabola. Here's, okay, y equals x squared. It's fairly easy to see. Here's the parabola. That's the graph it makes. You can see parabolas in suspension bridge and cables and the trajectory of things falling in free fall. Also, the backs of flashlight mirror, the mirrors and flashlights and searchlights give this parabolic mirroring cross section, which focuses all the light into a parallel beam. That's a whole other thing. Now, if you have the graph y equals ax squared, the way it looks depends on the value of a. If a is positive, it's a parabola cup up. If a is negative, it's a parabola cup down. And the bigger a is, the longer and thinner, or the bigger absolute value of a is, the longer and thinner the resulting parabola. So here's one for a equals 2. Here's one for a equals 1. A equals half. Parabola looks like this. A equals -1 and a equals -2 parabolas look like that. Now, if we take this ax squared graph and shift it around by making it a times x minus a squared plus k, that shifts the ax squared graph over to the right by h and up by k. So instead of having this vertex point at 0 by 0, the way it is with ax squared, it's over at h by k. So it's called the vertex. Now we can turn any quadratic into this form by completing the square. So if it's ax squared plus bx plus c, then factor out a, add and subtract a term, yada, yada, yada. You get f equals a times x plus b over 2a squared plus f of negative b over 2a. So its vertex is at negative b over 2a by f of negative b over 2a, looking like this. Cup up if a is positive, cup down if a is negative. If a is positive, this is a minimum of the graph. If a is negative, then this will be a maximum of the graph. Thus, so the minimum will be equal f of negative b over 2a at x equals negative b over 2a if a is positive. If a is negative, then the maximum f will be f of negative b over 2a at x equals negative b over 2a. So for example, here's a graph of here's y equals -2 times x plus 3 all squared minus 4. Where it's its vertex. So it's x minus h plus k. Well, okay, minus a -3 plus a -4. So the vertex is -3 by -4. This is a negative quantity, -2, so it's cup down. And the resulting vertex is a maximum. Here we have same thing, 2x squared minus 4. Well, this is 2 times x minus 0 squared plus -4. So the vertex is at -4. This is a +2, so it's cup up. And therefore, the 0 by -4 is a minimum value. Y is always at least -4. Here we have y equals x squared plus 4x minus 5 plus 5. All right, so b of negative b over 2a is -4 over 2 times 1 is -2. And if you set x equal to -2 and plug and calculate, you get y equals 1. So the vertex is at -2 by 1, and because this is a +1 in front of the x squared, it's cup up. So this is a minimum value. 1 is a minimum value of y. All right, fine. Similar things for y equals x squared plus 2x minus 3, complete the square, sign vertex in concavity. So what we do is we pull this -3 away. And so to complete the square, we take half of this 2, that's a 1, square it, that's a 1, add and subtract to get x squared plus 2x plus 1 minus 1 minus 3. These three terms are completed square of x plus 1. Minus 1 minus 3 is a -4. So this is x minus a -1. This is plus a -4. So the vertex is at -1 by -4. Because this is a +1 in front of the squared term, it's cup up. So -4 is the minimum value of y. What happens at x equals -1. Find the vertex of y equals 2x squared minus 3x plus 4, then graph. Okay, first, negative b over 2a will be -3 over twice 2, which is +3/4. And we plug 3/4 into this, get a value of 28/3. So the vertex is at 3/4 by 28/3. This this A is 2, a positive number, so it's cup up. So 2 times x minus 3/4 squared plus 23/4. It looks something like that. Sorry, 3/4 by 23/8 and cup up from there. All right, here we have E of n is 2/3 n minus 1/90th n squared. So what values of E maximize, what value of n maximizes E, and what is that maximum? First of all, it's certainly a maximum because this is a negative 1/90th in front of the x squared, so it's cupped down, and therefore we have a maximum value for E. All right, so we'll rewrite this, negative 1/90th n squared plus 2/3 n. So like I say, it's cupped down, and we'll have a maximum at the vertex. The vertex is when x is, well, n is negative b over 2a, which is negative 2/3 divided by negative 2 over 90, which comes out to 30. Oh dear, hold on a second. I'm gonna have to change some things. 3, 1, 6, 3, 1, 6. E at 30, not 3. Okay, so if you plug in 30 in here, not a 3, but a 30, you get 2/3 of 30 minus 1/90th of 30 squared, which makes 10. So maximum E equals 10 when n equals 30. Now here we have 2,400 feet of fencing to make a rectangular horse corral like that. What dimension gives it a maximum area, and what is that area? So we have this x by y with area A, and twice x plus twice y is 2,400, and A equals x times y. I want to maximize A. Okay, first we solve for y from here. You get 2y equals 2,400 minus 2x. So y equals 1,200 minus x. So A equals x times y is x times 1,200 minus x. After some distributing and rearranging, x is negative, A is negative x squared plus 1,200x. A negative x squared means that it's cupped down with a maximum vertex. So vertex is at negative b over 2a, that's negative 1,200 over negative 2 is at 600. And if x is 600, then y is 1,200 minus 600, which will be 600. So area is 600 by 600, or 360,000. And incidentally, it's a square. So most regular shaped thing is the one with the greatest area. So maximum area is 360,000 square feet, and a 600 by 600 foot corral. Okay.